Let's look at a few examples of how we can multiply and divide two complex numbers in their polar form, and then how we can also use a complex number in polar form and raise that complex number to a power. So just again, kind of a review of the process here. If we are multiplying two complex numbers, so we could just say z1 times z2, then you're going to multiply their radiuses, so r1 times r2, and then you're going to have the cosine of the sum of their angles, so theta 1 plus theta 2, and then plus I sine of the same thing, theta 1 plus theta 2. If you're dividing, so z1 divided by z2, or you could flip that division around. It doesn't always have to be 1 over 2. And if you do that, you switch all the other the corresponding parts. But z1 over z2, we're going to divide the r values. So just like we multiplied, we're going to divide down. And this time, instead of adding the thetas, we're going to subtract. So cosine of theta 1 minus theta 2. You always put the first, whichever z value is on the top, you put that as the first theta. So it's always the top one minus the bottom one. Cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. And just again, to do powers, if you have z to the nth power, so remember, powers are the same thing as just multiplying. So if you raise something to an nth power, that means you multiply it by itself n times. And if you multiply two numbers, you multiply the radiuses. So we're going to have r to the nth power times the cosine of n theta. And it's n theta because if you multiply complex numbers, you add their angles. Well, if you multiply them n times, then that means you're going to add their angles n times, and that's what multiplication is. So cosine of n theta plus I sine of n theta. So these are the formulas that we need to use to work through these three examples. So we have our first complex number, z1, is equal to 10 cosine of 2 pi over 3 plus I sine of 2 pi over 3. And then z2 is equal to 4 cosine of 7 pi over 4 plus I sine of 7 pi over 4. And so I just want us to go ahead and compute a multiplication, a division, and a power. Whenever we do this, we want to always list our angle. We want to make sure theta is always between 0 and 2 pi. Okay, if it's not, we can find the coterminal angle that is between 0 and 2 pi. All right, so let's try this first one out. So our first one here, we're going to multiply z1 and z2. And so that means I'm going to multiply the r values, which we already went through the formula. So we're going to have 10 times 4. And then you're going to take cosine of 2 pi over 3 plus 7 pi over 4 plus I times the sine of 2 pi over 3 plus 7 pi over 4. Okay, so that's what it's going to look like. We just need to now simplify it. So the 10 times 4, that's easy. If we want to add 2 pi over 3 plus 7 pi over 4, we need a common denominator, which at 3 and 4, the common denominator would be 12. So if I multiply the 2 pi over 3 times a 4, that'll give me 8 pi over 12. And if I take the 7 pi over 4 times a 3, that's going to be 21 pi over 12, which the sum of that is going to be 29 pi over 12. So z1 times z2 is going to be 40 times the quantity cosine of 29 pi over 12 plus I sine of 29 pi over 12. So the only thing we need to consider at this point, we've done the actual work. We just need to figure out, is our angle between 0 and 2 pi? Well, 2 pi is really a fraction. It's 2 pi over 1, which means 2 pi is equal to 24 pi over 12. So I need to make sure that whatever theta values I have, they have to be between 0 and 24 pi over 12. Well, 29 is not between 0 and 24 pi over 12. So to find the coterminal angle, I just take the angle I have, which is 29 pi over 12, and I subtract a 2 pi from it. Well, remember 2 pi is the same thing as 24 pi over 12. So 29 pi over 12 minus 24 pi over 12 is just going to be 5 pi over 12. So I can rewrite my complex number here, the result of this product, I can rewrite as 40 times the quantity cosine of 5 pi over 12 plus I sine of 5 pi over 12. Okay, and I can go ahead and leave it. I'm just going to leave it here. If we wanted to convert this, we could convert it into its rectangular form. You just have to figure out what the cosine of 5 pi over 12 and the sine of 5 pi over 12, what those are. Okay, but I'll just leave it there in complex form. All right, our second one, this time we're going to divide. So we're going to take z1 and divide it by z2. So that means we're dividing the r values. So z1 has an r value of 10, z2 has an r value of 4. So we're going to have 10 over 4 times the quantity cosine of 2 pi over 3, because that's the theta that goes with z1, minus a 7 pi over 4, plus I sine of 2 pi over 3 minus 7 pi over 4. Okay, so that's converted now into polar form. We just need to simplify the values a little bit. The 10 over 4 is easy to do. We're just going to we'll reduce that fraction. We need to do a common denominator, though, with our angles, though. So 2 pi over 3 and 7 pi over 4 have a common denominator of 12, which we just saw this here a minute ago. So this is going to be 8 pi over 3 minus 21 pi over 12. We do that subtraction, and we're going to get a negative 13 pi over 12. So again, is negative 13 pi over 12 between 0 and 2 pi? No, because it's a negative. So in order to convert it, to make it so that it is an angle between 0 and 2 pi, I need to take it and add a 2 pi to it. But remember that 2 pi is really a 24 pi over 12. So we're going to take that negative 13 pi over 12, and we're going to add a 24 pi over 12 to it. And so the result is going to be a positive 11 pi over 12. So when we go back, just to simplify our answer here, 10 over 4 reduces down to 5 halves times the quantity cosine of 11 pi over 12 plus I sine of 11 pi over 12. And again, I'm just going to leave this in its polar form. If you wanted to convert it to rectangular form, you just need to figure out what the cosine and sine of 11 pi over 12 is going to be. All right, for our last one here, let us just compute what is z1 squared. Okay, and sometimes you may see this, instead of using parentheses, you may just see this as z with a little sub 1 and then squared. So you don't actually need the parentheses, but it might help just clarify what the expression looks like. Okay, so remember our formula. If we raise something to a power, we also raise the r value to the same power, right? So this is going to be r1 squared. And then I'm going to take the cosine of 2 theta. So I'm going to multiply the 2 times the theta plus I sine of 2 times the theta. And if I did it instead of a power of 2, if I did a power of 5, I would have r to the 5th power and then 5 theta and 5 theta. Okay. So what does z1, z sub 1 squared look like? Well, what is the r value for z1? The r value for z1 is a 10, and the angle is 2 pi over 3. So we're going to have 10 squared times the cosine of 2 times 2 pi over 3 plus I sine of the quantity 2 times 2 pi over 3. Okay, and just to simplify, that is already computed. We just need to simplify it now. So 10 squared is 100 times the cosine of 4 pi over 3 plus I sine of 4 pi over 3. And so that would be the complex number in polar form that results from taking z1 and squaring it. And I can go ahead and leave it in complex form like that. Again, just to kind of remind you of how we would go about converting it back into the a plus bi form. This one is not as bad since it's the cosine and the sine are dealing with pi's over 3. So let's just do this one real quick. So we're going to have 100 times the cosine of 4 pi over 3. So cosine of pi over 3 is a half. 4 pi over 3 is in the third quadrant, so this is going to be a negative 1/2. So we're going to have 100 times a negative half plus I times the sine of 4 pi over 3. Well, sine of any pi over 3 is a root 3 over 2, and 4 pi over 3 is in the third quadrant, so it's going to be a negative root 3 over 2. Okay, so we have 100 times the negative half plus I times the negative root 3 over 2. If I multiply the 100 through, so 100 times the negative half would be a negative 50, and then 100 times a negative root 3 over 2 would be a negative 50 square root of 3, and then we have a times I. So this is what it would look like if we wanted to convert it into a plus bi form. Usually for me, I don't care. Just follow the directions, whatever the problems that you might be looking at ask you to do. If they want it in complex form and they want it in polar form, then leave it with the cosines and the sines. If you're asked to find it in A plus BI form, then you need to compute what the cosine and the sine actually are.